When I wrote out number 5, I realized this is going to be a long video. So I decided to go ahead and stop that one that we just did so that this one wouldn't get to be so terribly long. I'll probably put this one on one by itself. Number 5. If you roll 2 number cubes 30 times, how many times is it likely that the sum of the 2 cubes will be 7? So the first thing we need to do is figure out what the probability would be on one roll of these two dice, what that probability would be to get a sum of 7. So I'm going to list all the possible outcomes of the 2 rolls. So this is where this one gets to be a little bit long. And I think I'm going to draw a table just to organize myself, because this is going to get to be quite lengthy. Whoa, sorry. Okay, that's not allowing me to do what I want to do there. 3. And you can do this with me if you want, or you can just watch, whichever you prefer. If you're doing this with me, you need 6 columns. All right, so on the first roll of 2 dice, I could get a 1 on the first die. And then to go with that, I could get a 1 on the second, a 2 on the second, a 3 on the second, a 4, a 5, and a 6. So this would be, for example, if you look at 1, 1, I would have a 1 on the first one and a 1 on the second one. Or I could have a 1 on the first one and a 2 on the second one. Or a 1 and a 3, and so on. So of those, do we have any that add up to 7? Well, yes, we do. We have 1 right there. All right, on the first roll, I could get a 2, or the first die, I could get a 2. And then the second one could be a 1, a 2, a 3, a 4, a 5, or a 6. And do any of those add up to 7? Yes, right there. Okay, I could get a 3 on the first die. And then a 1, a 2, a 3, a 4, a 5, or a 6 on the second die. And so my 7 is right there this time. Then I could roll a 4 on the first one. And then on the second one, it could be a 1, a 2, a 3, a 4, a 5, or a 6. And then, of course, my 7 is going to be right there. I could roll a 5 on the first one. And our 7 on this one is going to be right here. And then the last possibility would be a 6 on the first die. And then these possibilities on the second die. And our one that totals 7 would be the 6 and the 1. So in one roll of these 2 dice, you have 6 possibilities of getting a 7. There are 36 possible outcomes because this one has 6 and this one has 6, and 6 times 6, remember the fundamental counting principle, says that you just multiply. So 6 times 6 is 36 possible outcomes. In all of those possible outcomes, 6 of them give us a 7 total. So the probability of rolling a sum of 7 is 6 over 36, which simplifies to 1 over 6. So you have a 1 out of 6 chance of rolling a 7. But remember, we want to do that for 30 rolls. So we would take that 1 out of 6 probability times 30, and you can do that on your calculator. You can put a 1 under there to get 30 over 6, and then that would divide on down to 5. This wasn't quite as long as I thought it would be. I thought I was going to have to take a little bit longer to write out that table, but it went pretty fast. So I am thinking the answer to this question is 5. I would expect 5 times that I would get a 7 if I roll those 2 dice 30 times. All right, let me put number 6 down here unless it's terribly long. A survey of 50 people asked which was their primary way of accessing the internet. 15 people said a smartphone. 25 people said a laptop. 8 people said a desktop. And 2 people said they did not use the internet. So let's make sure that this adds up to 50. So 25 and 15 make 40, and then 8 and 2 make 10. That is 50 total people asked. What is the probability that a randomly chosen person uses a smartphone as their primary way to access the internet? So we want to know that if we ask a random person on the street, what's the probability that he or she will say a smartphone? Well, in our experimental probability, we had 15 out of 50 who said they use a smartphone. And if you simplify that by 5, you should get 3 over 10. So that would be 30% or 0.30. All right, let me check these before we move on. And I think I'm just going to go back to the beginning there at text 76. Okay. All right, so here we go. Compound events. Oh goodness, I wrote the wrong word. I didn't look up my choices. I'm sorry. This should be compound event. Probability, tree diagram, independent event, complement, and dependent event. Number 1 is 1/2. Number 2 is 1/4. Number 3 is 1/5. Number 4 is 1/10. Number 5 is 5 times. Number 6 is 3/10. And then number 7 I will pick up on the next video.